6th International Physics Olympiad year 1972 IPHO. Problem number 1. 3 cylinders with the same mass, the same length and the same external radius are initially resting on an inclined plane. The coefficient of sliding friction on the inclined plane mu is known and has the same value for all the cylinders. The first cylinder is empty tube. The second is a homogeneous field, and the third has a cavity exactly like the first, but closed with two negligible mass leads and filled with liquid with the same density like the cylinder's walls. The friction between the liquid and the cylinder wall is considered negligible. The density of the material of the first cylinder is n times greater than that of the second or of the third cylinder. Determine A. The linear acceleration of the cylinders in the non-sliding case. Compare all the accelerations. B. Condition for angle alpha of the inclined plane so that no cylinders is sliding. C. Reciprocal ratios of the angular accelerations in the case of rollover with the sliding of all the 3 cylinders. Make a comparison between these accelerations. D. The interaction force between the liquid and the walls of the cylinder in the case of sliding of this cylinder, known that the liquid mass is ml. Solution for problem number 1. The inertia moments of the 3 cylinders are I1, where we have internal radius small r and the external radius is big R. This one. For second one we have totally external radius r, and for the third cylinder we have internal radius is the same as for the first one, external is for the same one, and also it's filled with the same density inside the cylinder of liquid. Because the 3 cylinders have the same mass, we have mass equal ρ1 multiplied by pi multiplied by r square minus r small square, which is equal to ρ2 pi r square h. And also we have that ρ1 equal n times ρ2. So from this data we can find that small r square equal big R square multiplied by 1 minus 1 over n. Now moment of inertia of all 3 cylinders could be written in form of I1 equal I2 multiplied by 2 minus 1 over n, and I3 equal I1 over n. It means that for n greater than 1 we have I1 greater than I2, which is greater than I3. For a cylinder rolling over freely on the inclined plane, we can write the equations. Ma equal mg sine alpha minus force of friction, I beta equal F force of friction multiplied by external radius, and the normal force equal mg cosine alpha, where beta is the angular acceleration. If the cylinder doesn't slide, we have the condition that acceleration A equal beta R. Solving the equation system from 6 to 8, we can find that acceleration A equal g sine alpha over 1 plus I over mr square, and the force of friction equal mg sine alpha over 1 plus mr square over I. The condition of non-sliding is next one. Force of friction must be less than mu n, which is equal mu mg cosine alpha. It means that tangent alpha must be less than mu multiplied by 1 plus mr square over I1. In the case of the cylinders from this problem, the condition necessary to show that none of them slides is obtained for maximum I. So we have I1 equal I2 multiplied by 2 minus 1 over n, which is equal mr square multiplied by 2n minus 1 over 2n. It means that tangent alpha must be less than mu multiplied by 1 plus mr square over I1, which is equal mu multiplied by 4n minus 1 over 2n minus 1. The accelerations for cylinders are a equal g sine alpha over 1 plus I over mr square, and in each case we have a1 equal 2g sine alpha over 3 plus 1 minus 1 over n, a2 equal 2g sine alpha over 3, and a3 equal 2g sine alpha over 3 minus 1 minus 1 over n squared. So it means that a1 less than a2, which is less than a3. In the case then all the three cylinders slide, we have force of friction F equal mu n, which equal mu mg cosine alpha. And from equation number 7 we have angular acceleration equal r over I multiplied by 1 mg cosine alpha. And for the cylinders of the problem we have such conditions that angular accelerations back proportional to moment of inertia, which is this one. So it means that beta 1 less than beta 2, which less than beta 3. In the case that one of the cylinders is sliding, we have ma equal mg sine alpha minus force of friction, where force of friction equal mu mg cosine alpha, and the acceleration a equal g multiplied by sine alpha minus mu cosine alpha. Now let's force F be the total force acting on the liquid mass ml inside the cylinder. We can write that force F in x direction plus mlg sine alpha equal mla, which is mlg multiplied by sine alpha minus mu cosine alpha, and fy minus mlg cosine alpha equals 0. And in that case we have force F equal fx square plus fy square, which is mlg cosine alpha multiplied by square root from 1 plus mu square, which is equal to mlg cosine alpha over cosine phi, where phi is the friction angle, tangent phi equal mu. So that was a full solution for problem number 1.